Dear students, yesterday we have discussed, in the last class, we have discussed what is transformer, how the transformer is constructed, how the AC power is transformed from the one circuit to another circuit, and how the AC input power is reduced to the low value, and the different types of transformers. The transformer working under the principle of mutual inductance, it produces the magnetic field. The input AC power produces the magnetic field when it passing through the primary coil, and then due to the inductance effect, the induced EMF is produced in its output. Depending upon the number of turns in the secondary coil, the output AC power is reduced. So using this transformer, we can vary the AC power. We can raise, we can increase, or we can reduce, we can decrease the AC power depending upon our requirements. In this class, we are going to discuss the classification of transformers, the different types of transformers, the shell type, core type, and depending upon the voltages and the construction. According to the construction, the transformers are classified into two types. One is core type transformer, another is shell type transformer. These transformers are classified according to their construction, how they are constructed, how they are designed. Depending upon the design, the transformers are classified into two types, core type and shell type. In the core type transformer, the cores are built with lamination of rectangular frame using L-type frames or I-type frames. The core is made up of L-type strip. It is a L-type strip. Two L-type strips are arranged like this, and the number of L-type strips arranged alternately to form the core of the transformer. The two sides, this is known as limb. It is a one limb, it is the another limb. The primary windings and the secondary windings are arranged concentrically with each other on cylinder around the side known as limbs of the core. This is known as limbs of the core. The core is made up of a thin laminated silicon steel strips. It is a L-type laminated silicon steel strips. They are insulated each other by means of a insulating material called as varnish. In the core type of transformer, the high voltage winding is placed around the low voltage winding. The high voltage winding, there are two types of winding, high voltage winding and low voltage winding. The high voltage winding is placed around the low voltage winding. See here, it is the low voltage winding, it is in blue color. Before that, there is a low voltage insulation, the insulation from the core strips and the coil, and then a low voltage winding is made here, a low voltage winding is wound here, and then a high voltage insulation is placed there, and then a high voltage winding coil is wound over the high voltage insulation. In the same way, here also the low voltage winding is first wound on the limb, and then a high voltage insulation is wound over it, and then a high voltage winding is wounded on the limbs. In the core type of transformer, the low voltage winding is always placed near the core. So the low voltage winding is first wound on the core, so it is nearer to the core. The cross section of the core may be rectangular due to the two L-shaped strips. Depending upon the shape of the strips, the cross section of the core becomes rectangular. But in the case of a large transformers, the shape is square type. The square type is depending upon the shape of the strips used to construct the core. If we use the equal length of L-shaped strips or square type strip, we can get a square typed cross section core. So the primary and secondary windings of core type transformer is wound helically. See here, it is in a helical shape. Helically, the layers are insulated from one another using the insulating paper. This core type of transformer is shown in diagram. So the insulation is made using a mica sheet or some proper insulating material. See here the low voltage insulation is given here. The high voltage insulation also given here. Next we see the shell type transformer. It is the shell type transformer. Here the magnetic cores are rectangular shaped cores. These are made up of the E-shaped strips, E-shaped strips and I-shaped strips. It is like E, alphabet E, and it is like I. E-shaped strips and I-shaped strips are arranged like this. So the body of the core is formed using these two strips. These are called legs or limbs. 1, 2, 3. 3 legs or limbs. So the magnetic cores are rectangular shaped legs or limbs. The cores are made up of a silicon steel strips. The silicon steel E-shaped or I-shaped strips, they are insulated from each other. In this shell type transformer, the windings are circular. They are flat circular rectangular coils interleaved with each other. In this shell type transformer, the first a low voltage insulation is there, and then a low voltage winding is wound on the low voltage insulation, and then a high voltage insulation is here, over which the high voltage windings are wound like it is shown in this diagram. The high voltage and low voltage windings are interleaved alternately to reduce the leakage magnetic flux. In the case of both type of shell type and core type, the individual laminations are formed using the strips, I-shaped strips or E-shaped strips or L-typed strips. The strips I-shaped, E-shaped, L-shaped strips are used to form the dimension, the shape of the core. So the magnetic flux is formed here. E1 is the input voltage, that is the high voltage. The number of turns in this primary coil, the blue color, is N1, and it is the now turns of secondary coil. So voltage is E2. So number of turns of the secondary coil is N2, secondary winding is N2, and the voltage appear across the secondary is E2. It is the core, it is the magnetic flux produced here. So it is the brief explanation about the core type transformer and shell type transformer. Next we see the another two types depending upon the voltage transformation. Depending upon the voltage transformation, the transformers are classified into two types. One is step down, another is step up transformer. The one more transformer is there. It is a impedance matching transformer. What is step up transformer? The number of turns, step down transformer. In this step down transformer, the high voltage AC is reduced into low voltage AC. The number of turns in the secondary of the transformer is less when compared to number of the turns in the primary. So the electromotive force, the voltage induced in the secondary winding is lesser than the EMF induced in the primary coil. So the voltage induced in the secondary winding is lesser than the EMF induced in the primary coil. This type of transformer is known as step-down transformer. This kind of step-down transformer is used in cell phone chargers, systems, the CPUs, the microprocessors, and etc. And a step-up transformer. This step-up transformer is to raise the voltage in the output when compared to input. The number of turns in the secondary of this transformer is greater than the primary coil. The induced EMF, that is the voltage produced in the secondary winding, is more than the primary coil. This type of transformer is known as step-up transformer. These transformers are housed in a metal tanks filled with insulating coil. This type of step-up transformers are used in our lab also to give the high voltage to the sodium vapor lamp and the mercury vapor lamp. So we are step upping the input voltage. So the step up transformer is used to raise the step up the voltage to give the more voltage in the output. And this step up transformer also used in the grids, power grids. So today we have seen the classification of transformers, that is the different types of transformer. According to the construction, there are two types, shell type and core type. And according to the voltage transformation, the two types, step down transformer and the step up transformer. And one more transformer is also there. This is an impedance matching transformer. In this transformer, the number of input coils, the number of primary coil is equal to the number of secondary coil. The number of turns in the primary coil is equal to the number of turns in the output coil. It is used to match the resistance between the two devices. So it is called impedance matching transformer. Okay.